Hello, I welcome you all to this another interesting screencast. The problem reads: a ball is thrown vertically upwards from the top of a 30-meter high building with an initial velocity of 5 meters per second. At the same instant, another ball B is thrown upwards from the ground with an initial velocity of 20 meters per second. Determine the height from the ground and the instant at which they pass. At which they pass each other. This problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. So before I start solving this particular problem that we're being asked about the two balls, one being thrown at the top of the mountain, thrown vertically upward, the other one being thrown at the ground, and they are all being thrown at the same time, and we are being asked to determine the height from the ground and the time at which they pass each other. At that instant when they just pass each other. So let's remind ourselves of the three basic equations: kinematic equations that we are going to be employing in this journey of problems and these problems are rectilinear. Okay, these are rectilinear motion problems, and by this we mean these are problems in a straight path or a straight line. Right, so we have the first equation, which is velocity, instantaneous velocity, which is the time derivative of position. Then we have acceleration, which is the time derivative of velocity. And then when we make dt subject to the formula for both and we equate this, then we have one derived equation. Okay. Then from the three, we are able to derive three more. And these three more are used when the acceleration is constant. So let's say the acceleration is equal to AC C for constant, and then time equal to 0. We have V, we have S naught and V naught. And these are the derived equation. S is equal to S naught plus V naught by T plus half AC T squared. Then we have another one, which is V is equal to V naught plus AC by T. Then we have another one, V squared is equal to V naught squared plus 2AC by S minus S naught. Okay. Again, we just wanted to remind ourselves of this particular equation. So now let's go back to our problem. We have, like we've been told, we have two balls. Okay. We have two balls, and one ball is being thrown from the top of the mountain. So let's draw the datum. Let's draw the datum line. Let's draw this so that we can represent them using a figure. Okay, so let's imagine we have a mountain of height 30 meters. Let's say there it is. This is our mountain. Okay, so let's say this is our mountain. This is our mountain, 30 meters, and then a ball is thrown. A ball is thrown from this point in this direction, like so, right? At this velocity, like so. So let's draw the path. So this is the path. I'll show it in red. So we have this path like so, and let's imagine the ball comes down like so. Right. Let's imagine at the same instant another ball is thrown. Okay, let's say maybe just go somewhere there like so. Okay, all right, and then maybe let's say it goes like so. There we go. So we have these two balls. So let me just draw this, because there will be a point when their velocity is equal to 0, and I also draw this one like so. Right, so let's draw the balls. So let's imagine this ball is thrown. This is the ball that is thrown, and it goes round. Let's say it comes up to somewhere here. Okay, and this other ball is also thrown. Maybe it is at this position. Okay, this is the ball that is thrown, and then it comes there. So let me just draw the path. Let me draw the path. So for this ball, we have this ball like this. Okay, there we go, to this point. And then also here we throw this ball, there we go, to this point. All right, so let me just dot the rest of this to say to continue there, and then I dot the rest of this like so. Okay, there we go. So we have these two balls. So there is going to be a point when their displacements are equal. Okay, so there we go. There's going to be a point when their displacements are equal, and that is what we're interested in. So let's say their displacement is somewhere here, the equal displacement. This is what we're interested in. Okay, so we're interested in that when their displacements are equal. Okay, so let's call this point here S. I mean, this is S. All right, and then this height here, we've been told this height is 30 meters, right, of this mountain. This is 30 meter. This is 30 meters, and then this is a mountain, of course. Okay, this is the mountain. Right, so here we have, so here the initial speed down here also, let me just indicate it. The initial speed here, I'll need to indicate it. So here down here, I'll say I have my VA, because this is A, this is A, this is B, this is B, and here I have my VB. Okay, and my VA is equal to my VOA is equal to 5 meters per second, and my VOB, this is my initial, is equal to 20 meters per second. And then S at that point will be equal to SA, which will be equal to SB. Right. So with this information, we are going to start. This point here is our datum. This point is our reference. Okay, surface. Okay, with S naught equal to 0. All right. This is the reference. We just say reference. Let me remove this, because we'll have two references for two equations. So with this information, then we can straight away write down our equations. Of course, we are going to go with this equation here. Which one here? The acceleration is constant, so we'll go with this one. All right. So let's start. So we're going to call this as SA. We start with SA is equal to, this is for ball A. Okay. This is for ball A. SA is equal to S node A, okay, plus V node A, okay, T is the same, plus half AC, and then we have T squared. So our SA node, our SO node is equal to 30 meters, okay? We are starting from 30 meters ourselves. So I'll include this. And then our AC, this constant acceleration, will be equal to minus 9.81 meters per second squared. And our VOA is equal to, like we said, 5 meters per second. Right. So let's go ahead. So we'll have SA is equal to 30 plus 5t minus half by 9.81 by t squared. So we are done with the first one. We can stop there. Let's go to the second part. So we have SB. This is for ball B. For ball B, we have this S node B plus V node B times T plus half by SCT squared. So S node B is equal to 0 meters, okay? V node B is equal to 20 meters, 20 meters per second, and AC is equal to minus 9.81 meters per second squared. Therefore, our SB will just be equal to 0. That one we said is 0 plus 20t minus half by 9.81 t squared. So we equate the two. We are going to equate these two. Okay, we are going to equate these two. This one here and this one here. So we equate the two. So once we do so, then we are going to have something like this. We'll have 30 plus 5t minus half by 9.81 t squared equal to 20t minus half by 9.81 t squared. Okay, so this part and this part can go, right? What do we remain with? We just remain with this. So this 20 can go the other side, or it can come the other side. So we'll have a 30 is equal to 20t minus 5t. Therefore, we have a 15t equal to 30. Therefore, the time t is going to be equal to, this is the time when the two balls meet. The time t is equal to 2 seconds. This is the time when the two balls meet. Okay, time when the two balls pass each other. Okay, right, so we found this time. So we're going to use this time now to compute the distance. So we are going to use this time to compute the distance. So let's do so. Let's do so. So to do that, of course, I can use any of the equations, but I'll use equation for SB. All right. So let me use the equation for SB. So I'll say, but all of them will give us the same result, right? Doesn't matter which one. Can even use both of them. So we'll say SA at time equal to 2 seconds is equal to, so just plug in the 2 in this equation here. Plugging the 2, what do you get? You get a similar answer with the other one. So grab your calculator. So we have 30 plus 5 by 2 minus 0.5 by 9.81 by 2 squared. Okay, so what do you get? I get a 20.38 meters. So 30 plus 5 by 2 minus 0.5 by 9.81 by 2 squared. Alright, let's use the other one, SB. We are going to find the same result again. Right, so what do we have? Of course, this is the equation here. Plug in 2. So 20 by 2 minus 0.5 by 9.81 by 2 squared. We find the same. And we are supposed to find the same. Okay, therefore, our S, okay, which is equal to SA, our S is equal to 20.38 meters. All right, this S here. Okay, this one here. So that is the time. Again, that is the height. This is the height. This is the height when the two balls pass each other. Okay, I think this is about it. Let's outline the solution. So we have this one here. Right, and then we have this one here. Okay, right. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.